Hello, class. I just wanted to post a quick video so you guys can watch again and review how to go through a mixed circuit. So our first few questions are going to help us later on. This says, what is the form of Ohm's law that solves for current? So we've been using this form, which is if we need to solve for current, for Ohm's law, we're going to say current is equal to our voltage divided by our resistance. And then we also have been learning about how to solve for our total resistance in series and in circuit. So that's question 1 and 2. Whenever we're in series, we should have an R total of simply our first resistor, R1, plus R2, plus R3. And this can keep going as long as we need. This can go all the way up to 20, 30, as many as we need. For parallel, we've learned it's a little bit harder though, so it's 1 over R total is equal to 1 over R1 plus 1 over R2. And again, just like our other one, we can keep going as long as we need. So R over R1 plus R over R2 plus R over R3 as long as we need. So that is our question 1 and 2. Now, what we're going to look at is this circuit below. We know that we can see R1 and R2 are in parallel, and that's because our current can start in this battery and go all the way around until it gets to this point. Now it can either go here or down here. So because it can go two different ways, it's in parallel. So we're going to try to combine these together first by using our equation up here. So I'm going to rewrite it this way. And so just like we've done before, I'm going to give my given for R1. R1 is 15 ohms. And to find ohms, I go to Insert, I go to Special Characters, and I can draw what an ohm looks like, and it pops up. Here we are. All right, so we have 15 ohms is our first resistance. Our second resistance is 44. Our equation we're going to use, since these are in parallel, is going to be this one up here, except I'm going to call it R12 instead of R total, because we aren't going to use all of our resistors, so we can't call it R total. We have to call it something else. And since we're combining R1 and R2, I'm just going to call it R12. Then our work, we just get to plug in our numbers for our resistors. We have resistor 1 and resistor 2, so it'd be 1 over 15 plus 1 divided by 44. This is when I would use a calculator because these fractions are not easy. If they're both under 10, I would try to do it by hand, but these aren't easy. So if I go and get my calculator out, all right, so we have 1 divided by 15 plus 1 divided by 44. My answer is 0.083, or 893. So 893, so 0.0893. We're not quite done yet. The way to solve for just R12 is to flip R12 with our number right here. So we'll have 1 over 0.0893 is equal to R12. And that means that R12, once we plug into our calculator, is going to give us, we have 1 divided by 0.0893, 939393, is about, we're going to call it 11, we'll leave it at 11 to make things easy. We'll say 11 ohms. So now that we've combined these two resistors, let's see what it would look like. So what it would look like is we'd have our battery first. We go around, and now we just have one resistor here and another resistor here. So we can see we have R12, now we have R3. Now we're going to try to combine R12 with R3 in our second step. So let's look at what step 2 is. Combine R12 and R3. We just found R12 to be 11 ohms. And we know R3 from our picture is 25. Up here we say 25 ohms. So I can say this is 25 ohms. My equation, if we look at our circuit now again, does it look like a parallel or a series circuit? Well, if our current goes through our circuit and can only go one path, one way, this is going to be in series. So we're going to use our series equation for R total. R total is equal to R1 plus R2 plus R3 for our equation. And this time it would actually be R12 plus R3. And then we get to just plug in for our work our numbers into our resistor, our variables, sorry. So we're going to say R12 plus 25 ohms. So I think everyone can do this addition maybe by hand or very quickly on a piece of paper, but we would get 36 ohms for our resistor. So let's look at how that would change our picture here. So I'm going to draw a new picture. So what we're looking at now is a resistor that would look like this. We've just combined two more. So now this is our total resistance, or we could also call it resistor 1, 2, 3, because we have combined three resistors into one. These are the same thing. We have all our resistors as if they looked like one. And now we can really easy do Ohm's law. Remember, Ohm's law is equal to V times IR. It can be I is equal to V over R, or R is equal to V over I. So now that we have just one resistor and one battery, we can very easily do Ohm's law. So let's try this. So this says our total, we just found is 36 ohms. Our voltage from our battery up here is 23 volts. And our equation is going to be I is equal to V divided by R. Then again, our work, we just get to plug in our numbers for our variables. So our voltage is 23 volts. We have 36 ohms as our resistance. And so that means that 23 divided by 36, 0.64 would be our current. And I'm going to call it amperes because that's what we measure our current in. So that's how we do our number three, question number 3 in these each different steps. I'm going to go through and now show you guys how to set up the rest of these problems, and then I'm going to let you do them on your own. So let's start with question number 4. So for step 1, what we need to do is we need to combine R3 and R4 so that we can go from a circuit that looks like this to a circuit that would look like a series circuit. So we're not going to save this one. So right now we have 4 resistors, and we're going to combine it so that our circuit would now look like this, where we just have 3 resistors. 1, 2, and 3. So we're going to try to go from here in step 1 to here in all in step 1. So the way we do this is, since they're in parallel, we would use our equation of 1 over R34 is equal over 1 over R3 plus 1 over R4. So I think you guys can use our example 1 to help you with that. So the next thing we need to do now is we have a circuit that looks like this. So let's see, is this parallel or series? Well, our current has only one path to go through our whole circuit. So it would be series. So we would use our series equation. That would be R total is equal to R1 plus R2 plus R34. Again, I think you guys can use our first example to solve for that. And then once we have our answer for our total, we're going to use our same equation, I is equal to V divided by R, to solve for current. So step 1, we're going to use our parallel equation. Step 2, we're going to use our series equation. Step 3, we are going to solve. for our current. Now let's look at this one. This one is a little bit different. Question 5 is a little different. So we have a circuit that looks like this. I'm going to make it a little bit bigger right now so that we can see it. We have a resistor here, and then our current can go either down this one or down this one. So our first step, what we want to do is try to combine resistors 2 and 3 so that we make it like a parallel circuit again. So we want a nice, easy parallel circuit. So we have a resistor here. We're going to combine 2 and 3 so that we have a nice, easy parallel circuit. So this is what we're going to. So this will be our R23, this will be our R1, and this will be RC. I don't know why they called it RC, but they did. So this is what our steps are going to be. So to combine R2 with R3, we need to use our series circuit. So we're going to say R23 series equation is equal to R2 plus R3. And then we'll solve for our work. The next step, now that we have it looking like this, is we want to combine R23 with RC. We want to combine these two together. So we would use our parallel equation, and we're going to call it R23C. And I notice I have a typo right here, so I'm sorry, this should be 23. And we're going to say this is going to be equal to R divided by, 1 divided by R23 plus 1 divided by RC. Just like this. And then the last step is combining R1 with R23C, which is again going to look like a series circuit. So we just say R total is equal to R1 plus R23C. All right, now this last one we don't have to do. If you guys would like to try it on your own, I encourage you guys to. What we would do here first, step 1, is a parallel circuit. These two are in parallel. Our 12 and 6 ohm resistors are in parallel, so we would put those together. And then step 2 is just series. So that's when we would add them all together in series and find our current. So I hope that helped you at least get started with these couple problems. If you guys have more questions, please let me know.